Okay, kiddos, here's the review for the Unit 5 test. If you haven't seen this yet, well, go ahead and watch it. But this just gets you ready for that Unit 5 test, and you can use this on the test then. Okay, simplifying radicals. This is where we can take out a pair of numbers out of that square root, but if you don't have a pair of numbers, they have to stay in the square root. So you're probably going to get it down to its prime factorization. So 90 is 9 times 10. 9 is 3 times 3. They're both prime. 9 is not prime. It's got to be only divisible by 1 in itself. And 10 is 2 times 5. So 90 is really the square root of, if you put them in order, 2 times 3 times 3 times 5. Now, the question is, what can I take out of here? How can I simplify this? Well, there's 2 3's, so I pull that out, and that's a root of 3 on the outside. That's like taking the square root of 9, which is 3. So there's 3 on the outside, square roots of the 2 times the 5. I can't take either one of those out, so I'm just going to multiply that, and my answer is 3 squared is 10. That's simplified radical form. 56, let's just do it like this. This is 7 times 8. 7 is prime. 8 is 2 times 4. 2 is prime. 4 is 2 times 2. Now, I'm not going to put 4 or 8 in there because they're not prime numbers. I just want the smallest numbers I'd multiply to get 56. So there's 3 2's and a 7. And I'm going to take out not all the 2's, but just 2 2's. That's like the square root of 4. The square root of 4 is 2. So when you take out those 2 2's, it's just a root, 1 2 on the outside. Square roots of, and then the 2 and the 7 stay in there, so that's 14. So that's 2 square roots of 14, and we're done. Okay. So when you multiply square roots, and we can do this, you can multiply any square root, you multiply the outside numbers, and there's nothing out there, so that's 1 times 1, so that's 1 on the outside. And you multiply the numbers that are underneath the radical, or the square root, whatever you want to call it, and that stays underneath there. So that's 300. So basically, it's just the square root of 300. Breaking 300 down, well, we know it's 15 times 20. We could do 10 times 30, same thing. 15 is 3 times 5. They're both prime. 20, I'm going to say 2 times 10. And then 10 is 2 times 5. I don't need the 10, the 20, or the 15. I'm just working with the prime factorization. There's 2 2's, a 3, and 2 5's. Now, I'm going to take out a pair of 2's. That comes on the outside. And I'm going to take out a pair of 5's. And what do you do with that 2 and the 5 on the outside? You multiply them. The 3 stays in there. So cleaning this up, 2 times 5 is 10. This is 10 square roots of 3. So that's multiplying square roots, or radicals. Here's a good one. Multiply the numbers on the outside first. 3 times negative 5 is negative 15. Square roots of 11 times 33. I think it's 336, or 363, sorry. So the 15 is out there, but I got to break down the 363 and see if I can take anything out of there. Well, that's 11 times 33. We just multiplied them to get that. 11 is prime, and 33 is 3 times 11. So it's actually negative 15 square roots of 3 times 11 times 11. So I can take out a pair of 11's. And that becomes a root of 11 on the outside. I'm going to multiply it by what's outside there already, which is 15. That 3 stays underneath there, stays underneath the square root. And then 15, actually negative 15 times 11 is negative 165 square roots of 3. And there we go. Okay, so the adding and subtracting, they have to be like radical terms. Like if I had 5 square roots of 2 plus 8 square roots of 2. They have the same number underneath the radical, so I can add these two up. 5, and then you add the numbers in front. 5 plus 8 is 13, and then it just stays the square root of 2, just like if it was 5x plus 8x. That's just 13x. You don't square it or do anything like that. You're just adding the numbers in front. Same with the radicals, okay? So we look at these, and first you see, well, can I simplify any of them? And you can't. If I look at 6, that's 2 times 3. I can't take anything out of there. They don't have anything in common. 5 is just 5, just 5. Once again, 2 times 3. I can't take anything out of there. There's no two factors that are the same, so everything's simplified. I just need to combine like radical terms. So I'm going to add 5 square roots of 6 plus 2 square roots of 6. They both have a square root of 6. You add the 5 and the 2. That's 7 square roots of 6. Now this is negative 1 square root of 5 plus 4 square roots of 5. Negative 1 and the 4 is going to give me positive 3 square roots of 5. And that's done. Okay? Okay, so for these next two, let me shrink it down here so you can read it. It says, find the solution to the following quadratic equations using the quadratic formula. Well, you got to remember the quadratic formula. Well, that's x equals negative b plus or minus the square root of b squared minus 4ac all over 2a, and then you simplify it down from there. So we're going to do this first one. So what's your a, b, and c? Well, a is in front of x squared, so this is my a, this is my b, and negative 4 is my c. So we're going to go x equals negative b. Well, you take the opposite of b. Well, if b is negative 11, we want positive 11, plus or minus the square root of negative 11 squared. Make sure you put it in parentheses. Minus 4 times a is 3 times c, right here, is negative 4. Right there, all over 2a, which is 2 times 3. So, working with this now. X equals 11 plus or minus. Okay, put this whole thing underneath the square root into your calculator. Find out what that number is. So, negative 11 squared minus 4, parentheses 3, and parentheses negative 4. And I get 169. Make sure you get that too. So we're all on the same page. And the square root of 169 is 13. So this is 11 plus or minus 13 all over 6. So here's the two parts to the problem where we break it up. It's 11 plus 13 over 6 and 11 minus 13 over 6. 11 plus 13 is 24 over 6. And you don't plug this whole thing into your calculator at once. Add, get your answer, and then divide. And that's going to give me 4. So x equals 4 is one solution. And 11 minus 13 is negative 2 over 6. You could simplify that down to negative 1/3. X equals negative 1/3. You could also write it as a decimal. You could say 0.3, negative 0.3 repeating, same thing, but we'll leave it as negative 1/3. Okay. So doing this problem now. First things first, it's got to be equal to 0. Everything's got to be equal to 0, so we're going to subtract 3 from both sides and get 8x squared minus 2x minus 3 equals 0. So my a is 8, my b is negative 2, and my c is negative 3. So plugging this into the quadratic formula, negative b, so take the opposite of b, which would be positive 2, plus or minus the square root of negative 2. Make sure you put it in parentheses, squared, minus 4 times a is 8, times c is negative 3, all over 2 times 8. So x equals 2 plus or minus square root of, well, what is that number? I know it's all over 2 times 8, which is 16. So negative 2 squared, make sure you put it in parentheses. Minus 4, parentheses 8, parentheses negative 3. and that is 100. And I'm hoping you know the square root of 100, wait a minute now, is 10, so this is equal to 2 plus or minus 10 over 16. So let's break it up here. That's 2 plus 10 over 16 and 2 minus 10 over 16. 2 plus 10 is 12, so that's 12 over 16. You can reduce that down to 3/4. So x equals 3 over 4, or you could put 0.75, that's fine. This is going to be negative 10, well actually 2 minus 10 is negative 8 over 16, and that's negative 0.5. So that's my other answer. You can I'll put negative 1/2, that's fine too. So 3/4 and negative 1/2 are my two answers for this quadratic equation. Okay. Now we're going to do a little factoring. This is kind of a review from the first quiz. First one's probably just going to be a general trinomial, x squared, x and a constant. So we're going to probably do the reverse box method. So I'm going to take that negative 5 times 12, that's negative 60. And I want factors of negative 60 that add up to negative 17. And then I can put those numbers in the box. In fact, I'll get my box started so you guys kind of know where we're going here. First I put in the 5x squared, and the last number is negative 12. Now these other two boxes are going to be what adds up to negative 17x, and that's where we're using this x right now to find the numbers that we'd multiply to get negative 60 but add up to negative 17. I'll start with negative 1 and 60. That adds up to 59. That doesn't work. Negative 2 and 30, 28, no. Negative 3 and 20, that's 17. Well, if I put positive 3 and negative 20, so that's 3 and negative 20, that will give me my negative 17. So I'm going to say 3x, I'll put the 3x here, and the negative 17x right here. So what do they have in common? Okay, top two, 5 and negative 17, I'd say that's just x. So I'm going to have to multiply oh, I screwed up. Let's back up here a little bit. I put 17 there, and that should be my fault. 20, this negative 20, x. Okay, so let's back up. Let's do this over again. Okay, so what can we take out of the top here? I can take a 5 and an x, so this is going to be 5x. Here I can take out, looks like a 3 out of both of them. Here I can take out just an x, and 5x times x is 5x squared. Here I'm probably going to take out, looks like a negative, and that's going to be a negative 4. So solving this, I got 5x plus 3 and x minus 4 equals 0. So now we got to kick in the ZPP, zero product property rule. And that's where you set them each equal to 0. 5x plus 3 equals 0, and x minus 4 equals 0. And when I solve these are going to be my two answers. So subtracting 3 from both sides, I get 5x equals negative 3, and then divide by 5. My first answer, x equals negative 3/5. Here I'm going to add 4 to both sides and get x equals 4. You could use the quadratic formula on this too, and it would still work out. You'd still get the same two answers. And it says to factor, but if you struggle with factoring, you can use the quadratic formula. This one, solving by factoring, there is no x, it's 0x. So if this happens, you check, well, can I use GCF? Do these two have anything in common? No, but I do notice that 25 is 5 times 5. It's a perfect square. and x squared is x times x. So I just factor this as difference of perfect squares, x and x, plus 5 and minus 5, to get negative 25 when you multiply. So, and then just kicking in ZPP again, x plus 5 equals 0, and x minus 5 equals 0. When you solve these, I'm going to subtract negative 5 and get x equals negative 5. Here I'd add 5 to both sides and get x equals positive 5. So if you did plug this into the quadratic formula because you didn't want to factor it, remember that's x squared plus 0x minus 25. So your a would be 1, your b would be 0, and your c would be negative 25, okay? But it's easy to factor that one, so I'd probably just factor it. Okay, so a couple word problems here. And you got to kind of figure out what we're working with. It says Ethan picks up a rock and throws it into the lake. He threw the rock with an initial velocity of 25 meters per second. The height, h of t, of the rock, t seconds after Ethan threw it, is given by this function. And h of t, this is kind of like your y, and the t is kind of like your x. So it's just a quadratic function. It says find the time that the rock comes down and hits the surface of the lake. Well, what we're working with here basically is a parabola. This is a quadratic, so there's a couple things. The rock goes up and then it comes down. You have to ask yourself, what am I looking for? Am I looking for the maximum height, which is the vertex? Or am I looking for when it hits the ground, or in this case, the lake, where my height is 0? That's meaning that h of t would be 0. And I'm getting these two solutions. Well, we want one of these two solutions. We want it hits the ground again or hits the surface of the lake when the height is equal to 0. And that's going to give us two answers, a negative answer and a positive answer. You do not want the negative answer. You want the positive answer. And you're just going to use the quadratic formula. Whenever they're talking about height, it's quadratic formula. But what is the height? Well, when it hits the lake, the height is 0. So this is negative 4.9 t squared plus 25t plus 2. So when it says when the height is 0, when it hits the ground or hits the surface of the lake, use the quadratic formula and take the positive answer. So plugging this into the quadratic formula now, x, or in this case t, but we'll just put x again, that's fine. Actually, we'll put t for time. Negative b, well, here's a, b, and c again. So negative b would be negative 25 plus or minus the square root of b squared, which is 25. Make sure you put it in parentheses. Minus 4 times a is negative 4.9, times c, which is 2, all over 2a. So 2 times negative 4.9. Okay, so a little bit of calculator work here. It's going to be negative 25 plus or minus some number under the square root. 2 times negative 4.9 is negative 9.8. Okay, 25 squared, make sure you put it in parentheses. Minus 4, parentheses, negative 4.9, and then parentheses 2. I get 664.2. So I'm going to take the square root of that. I get negative 25 plus or minus second square root, 664.2. I get 25.77, so I'm going to say 25.8. We'll just round it, that's fine. Negative 9.8. Okay. So splitting it up to my two problems now. One answer is usually negative, one's positive. You want the positive answer. So I get negative 25 plus 25.8 over negative 9.8. So adding those together, I get 0.8 over negative 9.8. So 0.8 divided by negative 9.8. I get an extremely small decimal. I get negative 0.08. That answer is not going to be right because it's negative. Like when it goes up and down, that would be the negative answer right there. Right there. And we don't want that one. We want when it goes up and then comes back down and hits the ground, or in this case, the lake. That's the answer we want. And that's the positive time. And that's going to be negative 25 minus 25.8 over negative 9.8. So it's going to be a big negative number divided by another negative number. It's negative 50.8 divided by negative 9.8. Ooh, what do we get? 5.18. So I'm going to say 5.18 seconds. And there's my answer. That's when that rock goes up and comes back down and hits the ground. Okay? Okay, this next one's kind of a two-part question. It says the height in feet, that's your h of t again, right there, of a baseball, t seconds, so time is in seconds after being thrown, is given by this function. What's the maximum height the baseball reaches and when does this occur? So this is the way you got to look at this. They want maximum height. So this ball goes up and comes down. Okay, the maximum height is, I'm not going to use the quadratic formula for this. I'm going to find the vertex. And that's x equals negative b over 2a, or in this case, t for time. That finds the time. It says, what is the maximum height the baseball reaches and when does this occur? So we got to find the time first, and then we'll find the actual maximum height. So using this again, a, b, and in this case c is 6, I'm going to find, well, in this case, t. It's x equals negative b over 2a, but in this case, x is t for time, so I'm just going to plug in time. T equals negative b over 2a. That's the formula used to find the time of the maximum height. Basically, right here, what time? And then we'll plug that back in to find the height. Negative b would be negative 24.5 over 2 times negative 4.9. So this is negative 24.5 divided by negative 9.8, which is going to give me 2.5. And that's 2.5 seconds. Okay? So if they ask what time does it reach its maximum height, you say 2.5 seconds. Now, the height is actually going to be this height right here. You got to plug that 2.5 in. So negative 4.9 times 2.5 squared. Don't forget to square that. Plus 24.5 times 2.5. Let me try that again. And then plus 6. So just plug this whole thing into your calculator, just the way you see it. Squared plus 24.5 parentheses 2.5 plus 6. And that gives me a grand total of 36.62, so I'll say 36.6 feet. That's the maximum height of the baseball, and it occurred at 2.5 seconds. So if they talk about maximum height, that's when you're using this formula, the vertex formula, okay? Now it says down here, how long does it take the baseball to reach the ground? So when it hits the ground again, when it hits the ground, that's when you use the quadratic formula. So we're going to be saying x equals negative b. Well, b is 24, so that's going to be negative 24.5 plus or minus the square root of b squared, well, 24.5 squared, make sure you put it in parentheses, minus 4 times a, which is negative 4.9, times c, which is 6, all over 2 times negative 4.9. And this is to find when it hits the ground. We don't want the negative answer, we want the positive answer. So a little bit of work here now. Negative 24.5 plus or minus the square root of what? What's this number underneath here? I know this number is negative 9.8. 2 times negative 4.9 is negative 9.8. But 24.5 in parentheses squared minus 4 parentheses 4.9 and 6 parentheses. I get 717.85. Okay, let's take the square root of that. Okay, so x equals, well, t, negative 24.5 plus or minus, well, taking the square root of that number, 717.85, 26.79, all over negative 9.8. And here's where we split it up into the two equations. Negative 24.5 plus 26.79 over negative 9.8. And negative 24.5 minus 26.79 over negative 9.8. Okay, and these are where we're going to get my two answers. I get 2.29 over negative 9.8, which is negative 0.23. That answer I don't want because it's negative. Down here, I get negative 24.5 minus 26.79, negative 51.29 divided by negative 9.8. I get 5.23. So it goes up and comes down and it hits the ground again at this time, right there. 5.2, whoops, 2, 3 seconds. That's my final answer. Whenever it hits the ground, you're going to use the quadratic formula. When they want the maximum height, that's when you use the vertex form, okay? That's the difference between these two. So go ahead and take your test. When you're done, submit it. If you have any questions or anything like that, you can send me a message. I can try and connect with you and help you out a little bit. But let's try and get this in before the end of the try. Good luck, and we'll see you soon.